Are we live? Okay. Okay. Hello everyone. So कैसे हैं आप लोग? So how is it going, guys? I hope you actually practiced whatever we did yesterday, and you do have a good gist of whatever we covered. You know about NumPy and Pandas, because we will be seeing both of those again. So yeah, let's start and see how exactly the data analysis and the predictive modeling works, and let's see how we can actually cover in these 1.5 hours, right? So let's get started. So before actually diving into the data analysis part, how many of you actually okay, right? So let me share my screen first. All right, I hope it is visible. Okay, so the first thing that we will be seeing will be the data science, of course. Sorry, data analysis and visualization somewhat. Second, we will be seeing the regression model or the machine learning part, how exactly it works with a simple example, not so much complexity at all, along with the machine learning. That is what our motto is for today's 1.5 hours session. Okay. So what exactly the data analysis is and visualization is. So before actually diving into the code base, I would love to give you an intuition about how exactly it works and how is it useful in a longer run. Okay. So I have a slide for you guys that you might enjoy. Okay. So let me just present it. So this is data visualization and analysis by Gopal, of course. Okay. So what exactly it is? Analysis is a process of extracting the useful information or observation from the data that actually helps you to strong in stronger decision making for any tasks. Like you would like to remove you would like to remove a feature, or you might think, okay, this feature is not making that much sense, and sometime you might want to truncate the feature. So those sort of things. Okay. And visualization, the moment you are done with the analysis, you tend to visualize them over the bar chart, uh, pie plot, and stack bar graph, etc, etc. All right. There are pair plots, like there are a lot of variations to the plotting for the data visualization. So these are some of the plots that we must have actually saw in one of our day-to-day lives. Okay. Maybe the task could be like your um, program for college presentation, or it could be somewhat like your office works, where are you actually managing some pie charts and everything. Okay. So these are some of the most not the lower one, but the upper ones are the most common plots and charts that you must have come across while dealing with the data, maybe in your Excel sheets as well. Okay. So how exactly it works, I can actually tell you with a story. I love stories when I like to explain something. Okay. So let's actually focus upon this story and see how it actually works in a longer run, like how a data makes sense, and how you can don't end up being a fool while uh, so dealing with certain files like CSV, image file, or maybe in for even for the let's say like text file, any file. Okay. So let's the conversation actually occurs between two of the Viltrum Incorporation people or employees. One is the boss, of course. His name is Nolan Grayson, and he is Mark Grayson. Okay. So Nolan on a certain day asks Mark that, why don't you actually give me an insight about how many people's got laid off from the Viltrum Incorporation due to the Corona crisis? And It is a real fact that people did actually got laid off from their respective jobs, from their respective companies, because due to the corona. So Mark, being Mark, he says, okay, sure, give me like 10 minutes. Okay. So just after the 10 minutes, what he does, like what he did, hey, I found a CSV file which consists of 200,000 employees. Okay. And you just can, like, okay, if the CSV is in a good format, everything is there in a good written way, and not so much jargon or not so much gibberish values, that time you might actually consider it even reading it in samples, like for 200, 200, 200, maybe for 100 time, for 100 times, still not that much you know feasible for any human being. But the file that actually Mark presented in front of Nolan was somewhat like this, and I don't think so it is pleasing to your eyes at all, right? So Nolan actually, by naturally, he gets infuriated and says, like, it is not even possible to make any sense out of this data. And it is true. Even if you actually have a glance at it, you just can't see what exactly is happening right now. And he actually asked a binary chart, like binary answers, how many people actually got laid off and how many people are still there in the Wilterman Corporation. Okay, so he got infuriated. So he actually starts to teach his intern, like, when we have a classified feature, it's always a good idea, and of course the cardinality has to be lower, less than 10. Otherwise it usually becomes hard to read pie charts. So he says, okay, when you have classified features, then it's always a good idea to use pie plots. Okay. So and again he says, okay, think Mark, think a pipe load makes more sense when we are making segment based observations, right? And it is true. Like, and Mark was just an unpaid intern who joined for the experience, right? But it is true, what Nolan is saying is true. When we have a segment based data with the lower cardinality, let's say here, it's always a good idea to make a pie plot, right? So that is why you should always take insights from your data before proceeding for any predictive modeling, right? If you don't do that, you won't be having any idea about, like, what features I need to keep in, how many features are making sense or not, like basically analysis and insights that you need to extract the moment you start your any data science project. And believe it or not, it will be the case for the 90% of the times. Okay, you will be dealing with the data, like only for the 10% or maximum to the 15% you will be doing the predictive modeling, because you just train the model and it just train it on itself. You just tweak it again, then you just again leave it for a while, train it on again. But for the data analysis and visualization part, you just have to sit on your chair and just go through the data really carefully. Okay, right? So that was it, like, that was a small just about how exactly the data analysis and data visualization works. Okay, so what we can do here is, why don't we just actually take a good example about how everything works. Okay, so we saw, like, pandas and numpy yesterday, but we haven't seen these two libraries yet. Okay, what are these two libraries for? Matplotlib and Seaborn are widely used for their data visualization techniques, not techniques, but for the tasks. Okay, be it for bar chart, pie plot, and anything that you want, that you would like to do. Okay, so let's actually start to understand what exactly the analysis and how we can actually interpret the values from the data. Okay, so I am just gonna go one over one. Okay, so one by one, like with the each plot, and it doesn't make sense if I just start to code in front of you. I will be like, we will be sharing the Let's Upgrade community, and we'll be sharing this notebooks with you, so you can always have a look at them. Okay, So let's get started. So these are your new libraries that you need to install. Just matplotlib and cbon, that's it, that's all you need to do. Okay, we already installed these two yesterday. Okay, so now what I am doing, we saw these commands yesterday, like np.random.rand and np.random.randan, right? I am just generating a random data set. Okay, and the data set's shape is this 10 by 1 10 by 1, like the 10 and 10 one. Okay, I am now, what we are studying about is the scatter plot. What exactly the scatter plot is in the first place. Okay, so you must have actually heard about the Cartesian system in your, maybe in your 11th grade or 12th grade, maybe in your 10th grade as well. Okay, I don't remember when exactly we had the chapter for the Cartesian system or two dimensional geometry, right? But for the Cartesian system, you are given two pairs of what? X and Y, right? Say this is your X and this is your Y. And in one of your classes of your mathematics, you must have actually drew what? The graphs, right? How exactly did you do that? You just took the X value and value, and you just plotted it out. Like this could be your x1 y1. Okay, and then this could be your x2 y2, and so on and so forth, right? So scattering of your data is nothing but scattering of xy coordinates over a Cartesian plane or an xy plane, right? When it is 2D plane, obviously it's an xy plane, but when it becomes 3D, we tend to get an extra dimension, which is the z-axis, right? So the moment you are plotting scatter plot over the 3D plane, you tend to get extra axis, which is your z, right? And we will be adding xyz there, right? So this is how exactly can we read this. So what we read it, this is your y and this is your x, right? So let's say your x is 2 and your y is 4. So what will be the value for this x and y? 2 and what? 4, right? These will be the values. Quite easy, right? Not so much hard at all. So this was your scatter plot. All right, so now wait a minute. There you go. Okay. So now what we did, I just took an alias of what? Dot pyplot method, and I'm referring it as PLT. Okay. And you will be doing it most of the times, believe me. And afterwards, I again took an alias of cbon as an SNS. Okay. So yeah. So pyplot has a method called scatter, which takes the x and y values. We are giving it right now, and just whenever you actually, let me just zoom it out a bit. So whenever you actually do this, like plt dot scatter, without it, it will gonna work. Okay, no issues. But it is always a good idea to title your plot, to label your x-axis, to label your y-axis. Why am I saying it? Say you do have an idea about like what this plot was all about. Okay, just for now, because you are working on it. But let's say for like 30 minutes or maybe for like 1 or 2 days later, you don't have any of these labels here, and neither you actually titled here the plot. So you will be left with the confusion only, and you wouldn't be having any option other than rerunning your entire code. So if you don't want to do that, please try to make your plots as detailed as possible by labeling them out and putting a title on it. That's always a good practice to follow. Okay, so just flattening it out. Flattening is again a numpy's function. Okay, what it does, it takes every value from the array and push all values into a single vector. So say we had values here like in 3 by 4 column, sorry, in a 3 by 4 matrix. So what it will gonna do, dot flatten method, it will just gonna extract all 12 values from the matrix and just going to push those values into a single vector. So that is how a flattening works. So these are nothing but to show you how what were the values there, like here. Okay, and now changing the color, you can always change the color as well. How? Like just by passing the c is equals to red, quite easy, right? And again I am detailing my plot here. How? Title, x label, y label, and show, right? And let me just actually start this everything up so that we can actually see everything in action. Okay. Okay, I did not install Plotly. I might have to. It won't take much time, but guys, don't worry. Okay, so now we have our Plotly installed. Let's rerun everything again. Okay, right. So now let's actually see the data iris here. How many of you actually heard about this data iris data set? Like it's nothing but a plant-based data set where you are given four classes, Setosa versicolor, three classes, sorry, Setosa versicolor and Virginica, and based upon the features, sepal length, sepal width, petal length, and petal width, you have to define which of these features associate with one of the classes, whether it is Setosa, whether it is versicolor, or whether it is Virginica, right? So I believe you must have actually heard about this if you know have any exposure to the data science or data analysis. Okay, so this is your Plotly. Okay, you can do in the same manner here with the Plotly as well. Like I just plotted it out, but it is more interactive. uh, like in compared to this, it is way interactive. You can just point it out and you can just see like which species is that Setosa with the width this much and high length this much, and you can tell like this is versicolor and this is Virginica. All right, and we have legends here, and you can even pan this out and zoom this up. Like these are your options that Plotly comes along with by default. Okay, so let's actually what if you actually want to change the size of the dots as well for the each of the xy coordinates? You just have to pass on the s is equals to whatever the integer value that you would want to. I believe it is like it takes the html value for rem, if I am not mistaken. I just don't remember what exactly does it take. Let me, s is equals to n. Okay, S, there your SR. Okay, but they haven't actually mentioned it either here. So yeah, I believe it takes a pixel value, and according to that it resizes and shrinks the value, or x double makes bigger the dots. That's it, what I meant actually. Okay, so let's see that in action as well. So you, when the moment you actually pass on the s is equals to 100, so Initially you had these, so we have now an increased size these. So yeah, labeling the data points. What exactly do I mean by that? So say, without labeling of the data set, what exactly will gonna happen? Say I just remove these two. What will gonna happen? Okay. Now we don't know if the data set, like what I exactly did again here, you can see, like I just created two random data sets with the x1 y1 and x2 y2, and I put that data set into a matrix form. And a funny thing is, that is how you always define your data set as well in machine learning. Okay, I will gonna come back to it again because it's, I believe this lecture is also about the machine learning part as well. We won't be delving into that much deeper, but yeah, we will be covering this part for sure. Okay. So yeah, this is how you actually deal with the, that is how your data is mostly formed most of the times in a matrix format. Okay. So say I actually passing the x1 y1 a green color and x2 y2 a red color. Okay. But just by looking this data, like I don't know if I have passed the green to the code, because as a user I only care about the visual visual results that I am getting right now. I am not a coder. Let's just assume that. Okay. So can you actually reduce it? You might actually can reduce it, and you might try, like just putting your finger here, and you might actually see, okay, the value for x-axis is getting this much and for y is getting this much. So it might be that coordinate, but it could work for, let's say, 10 number of data sets or data points. But what about like million or like 100,000 data points? Then that might be not the case. Okay. So in that case, it is always a good practice to label your data set, or label your any data point per se. Okay. So I can tell now, like my red one is from the x1 y1, and my green one is from x2 y2, right? I hope it is actually making some sense to you right now. Okay, so now the way we did, like this changing the shape, sorry, increasing or reducing the shape, we can now change the shape as well. By what? Giving a parameter called marker, and giving it a certain value. The value could be like here asterisk, a caret sign, and a k dash dash. Like basically k stands for black color, but not dash dash for dotted line, etc, etc. You can check a marker in the PLT's, or sorry, Matplotlib's documentation. There will be a much better documentation about what are the markers that you can use. Okay, let me just, yeah, there are the markers. Okay, but they okay, they haven't actually defined any markers here. So we might actually dig into the documentation and see what exactly we can use in the name of the markers here. Like I do remember, this actually produces a triangle when we pass in a caret sign, and for the asterisk it produces a simple asterisk or a star value. Okay, so let's again rerun this. Now we just edge color, we have now different shaped coordinates. Now coming to the edge colors. Okay, for the edge colors, what exactly the edge color is? Your parameter. And for the circle, obviously circumference is also a parameter for the circle, right? So your parameters color, basically what the region or the shape that is enclosed by the parameter. So that is your edge color. So for the k, it's black. Okay. For the y, obviously it's yellow. So you can also pass on the edge colors here as well. Okay. And shorthand syntax, since till now we have seen like passing on these multiple parameters. What about using it in a single go? How exactly you can do that? It's quite easy. Just pass on this red color o value. It will just gonna give you a circle, and green color and caret sign. Okay, it will just going to return a triangle in green color. So instead of scatter, now we are using the plot function, right? So this is how, and again we are labeling them out as well. Okay. So yeah, the same results. Okay. Obviously we are not choosing any size values here, but yeah, it will be the same for the coordinates because the coordinates are the same. And now next comes is the line plot. And what exactly is the line is? Line is nothing but your concatenation, or concatenation of from your two or more consecutive data points or coordinates, right? X1 y1 to x2 y2 to x3 y3. If lines are collinear, they will just gonna form a straight line. If the lines are not collinear, what they will gonna form? If there are the 3 points, they will gonna form what? Triangle, right? And if there are 4 points, if two are collinear, either of two are collinear, they might form a triangle or or a square or trapezium as well. Yeah, it trapezium, not trapezium. Yeah, trapezium as well. Yes. And yeah, so now you know what exactly like the line plot could be. I just took a simple value for 50, 100, 150, 200, 250, right? And these are your x-axis. So when you pass on plt dot plot, what it does, it takes the value automatically on the y-axis, right? And it just printed that value here out. You can see it right now here, 50, 75, 100, 250, right? And for the x axis, it divides those values. That's it. Like how many values do we have here? 5. Okay. So when you just see like till 5, or like if you actually include 0 as well, so 0, 1, 2, 3, 4, these are the 5 values. Okay. So that is how. What if actually you want to change the values for the x-axis? It's quite easy. Okay. Let us assume x label plt dot x ticks, and those x ticks will be list of a b c, oh, sorry, a b c d e. I believe these are the 5 one. Okay, wait a minute, I believe. Okay, I should not do these. Okay, so now I don't have any values since I didn't pass any. So let's actually see 1, 2, 3, 4, 5. So you can even change values the way I did. I just did. Okay. But instead of actually going from 1, why don't we actually go from 0, 1, 2, 3, and 4. Right. And yeah, that is actually much better. And you can do the same for what? Y-ticks as well. How you can do that? Just copy this out here and paste it here. In what? Y-ticks. Okay, and now you have 50, 100. So yeah, quite easy, right? So you can change the ticks value here as well, tick values. Okay, and what about like passing on the x1 and y1? So you can see x1 and y1. X1 we have till 4, and for the y1 again the same value, not so much fancy. And again changing the color, we just change the color with what? C is equals to quotation R, basically the red color, into the red color. And changing the width of the line, how thick a line could be. So line width is equals to 20. So initially we had this width of line. Now we have around like this width of line, which is quite thicker than the previous one. Plotting two lines on the same graph, what exactly do I mean by that? We could have same scale for the x axis but on different y values, right? So that is what I did here. If you see, okay, so I have x value for this much, okay, and I have y1 here, a different value for y1 and different value for y2. And now what I am doing, I am passing on x for y1 for the same, and x, basically x for the y1 and x for the y2. For both of the x will be the same for y1 and y2. Okay, so the moment I actually plot it out, you can see like, okay, now I can even compare two lines based on same scale. So if you have two entities that you would love to measure on the same scale, that's where you can use this. Like you can just simply plot it out on a same x scale, and you can measure the differences or dissimilarities, right? uh, okay. uh, all right, so around like 40 I can take questions, so please prepare your questions. It is about to get in, data analysis part is about to finish, and that afterwards we might see somewhat machine learning as well, so please prepare your questions if you have any. Okay, so after that we can even pass on the dotted line as well. Okay, and dashed line as well, line style. So for that you can just have these and these. So this is your dashed and this is your dotted. You must have actually saw these in your mechanical labs, like in your mechanical, in your first year for your mechanical labs. If you haven't, like, okay, in your first year college of your engineering, that's what you do. In the second sem I believe, right? And the line plot with this scatter plot. Okay, so yeah, you can do the same for the scatter and the line. Like you can just play it out right now with every plot that you would love to. What I exactly did here, I just plotted out two values, two types of plot on a same scale. One was the dot plot, or I could call it like a scatter plot, and one is the line plot, right? So yeah, you just have a good understanding of the API, and you can just literally play it out with the entire data, with the entire codes. Okay, and the subplots. Now coming up the part of the subplot. What exactly do I mean by that? We have been plotting out single plots till now. So what about, like, what if actually I would love to have 4 by 4 plots that shows different values, right? That could be the case. So in that manner, or in that case, what you can do, you can just use subplots, plt dot subplot. Okay, so what it does, it takes the one to one. What exactly do I mean by that? Let's just actually go in here and understand this. Not here, but here. Maybe because yeah, let's just actually. So what exactly does this? What exactly the subplot do? One to one. So this is nothing but your m, n, and order of your plot. What do I mean by that actually? I mean by that, I take two subplots over an axis. Okay, over an axis that should have single row with two columns. Okay, and for this one, the moment I say plt dot subplot 1, the value should get rendered in this plot, because this is my number 1 plot. And the moment I change this value to 2, it will just gonna shift to the second plot, and second plot will gonna get rendered the values, right? So this is what your plt dot subplot is about. Okay, so yeah, you can see it like 1 to 1 and 1 to 2, the same thing that we did here, right? 1 to 1 and 1 to 2. Okay, and again the same thing that you did initially, like plotting the data x and y, like, right? And again titling it up, and again x label and y label, and then calling out the legend. Legend is basically for your red line and green line. These are your legends, right? I think I forgot to mention what they were here. Sorry, extremely sorry for that. These are actually your legends, and the labels that I was actually talking about initially, like early, right? So plt dot legend. If you don't call this method, this will not gonna show up here. So it is compulsory to call plt dot legend. Okay, so again coming back to where we were, this is your subplot. Okay, now what I am doing, I am just taking two subplots, and then afterwards what I am doing in this line is adjusting those subplots. Okay, let's actually plot it out. And what if I actually just comment it out and see that in action, nah, not so much pleasing, like not at all a good plot, right? So what we can do, this is much better. So what exactly does it do? Like just shift from the left and right. Okay, so yeah, it actually creates the space, a marginal space. If you know about HTML or CSS, if you do have the knowledge about the what we call it, like the box model, right? Margin, padding, and whatever we have, CSS box model, right? So this is how it actually works. So stretch it out and give it a height. Okay, all right. So next comes is the bar chart. Okay, what exactly the bar charts are for? Bar charts helps you to visualize a numerical value for a particular category. Okay, let's say I have a bar chart for this, and I want to know what was the revenue for my company for the last 5 months. So I can tell, like for the C and D months, my revenue was at its peak, but for E months it was the lowest, right? So that is where your bar chart actually comes handy. Whenever you have a numerical value or numerical representation of a data, that's where, and of course the categories, but just remember guys, like for the categorical values, when you are dealing with the bar charts, the number of categories should be somewhat limited. Like, let's just say you, if you want to create a bar chart for 100 values, I don't think so you can, but that won't be feasible at all, right? Because I don't think so that it will be able to render it out here. You can maximum print out like around like 20 or 25 to make some sense. More than that, it just gets congested and doesn't give any idea about what is happening in the data set. Okay, so yeah, so let's actually see again the color schemes. Okay, so what I did again, I just used the subplots, okay, for 1 to 1 and 1 to 2, then the bars, okay, and then again what, the title, and for the title color red and color green, and for the width I can even change the width of my these sticks. Okay, these values, these sticks I can change. I just did with the width point 2. So the so from the original value it should shrink by point 0.2 value. Okay, that is what it means. All right, and again I am adjusting my two of my subplots, and lastly pld dot show. That's it. Okay, quite easy, right? And afterwards the horizontal bar graph, what it means, this is just a sibling of your vertical bar graph but the horizontal manner. Okay, and what you are calling it, bar h. So again the same insight, and how exactly it is useful. Let's say you have 30 or 35, so maybe you won't be able to list every category in an horizontal manner, sorry, in a vertical manner, but it is quite possible to go till down in a horizontal manner. Okay, so that's where it is a better, it could actually shine in more categories, but again it will be limited for more than, let's say, 30 or 35 maximum. Afterwards it is again going to get congested. Okay, and now comes the last one, not the last one, after I have like more or two, stacked bar graph. And what exactly do I mean by that? Okay, so for the gold one, okay, these are the 20 values. So, and for the bronze one, these are the 31 values. And for the 41, for the silver one, these are the how many values? 41 values for the silver one. Okay. And for what? For which nation? For the US. For the US, just actually assume this entire code into a matrix. Just forgot and just actually neglect these values, just don't see them at all right now, and put these values here like USA 20, 31, 41 for the gold, bronze, and silver. That is what is happening right now. Okay, this is your stacked bar graph. And how exactly it is useful? When you have a, let's say we have a gold class here, sorry, we have a medal class here, and that medal class has subclasses, and the subclasses are gold, bronze, and silver, right? So when you have a class, and to that class you have subclasses, and you want to observe how many of the data actually we accumulate with each of the subclass, and with respect to each of the subclass, that's where you can use your stacked bar graph, right? So now I can see, okay, I can say USA has won how many medals? 82 medals, sorry, 92 medals till now. But out of those 92 medals, how many of were they gold, bronze, and silver? Okay, and same goes for what, China and Russia. And how am I exactly plotting it out? Bar, plt dot bar, we saw it already on our upper sections. Okay, bar, and again I am putting the x value, my category values, right? And the gold ones, so these are your gold ones. And color, for the gold I am taking it as y because of the yellow one, and labeling it with the gold name, that's it. And again, x, bronze, and bottom. Why, what exactly do I mean by that? Since now we have stacked each gold values, these gold values will gonna work as a bottom for the next stack, or for the next subclass value, right? Or the next subclass value that we have here is the bronze one. So I am just putting up here is as bottom should be gold. This is actually gold, and I want to plot the bar graph as a stack one for the bronze here. Okay, so for the bronze, it will gonna use the bottom as gold, and the same goes for what, silver. It will gonna use bottom as gold plus bronze, gold plus bronze, gold plus bronze, and we will gonna plot it out as bar here as silvers. All right, I hope I have made myself clear here. Okay, and again, next sibling again. Okay, what it is? The stacked horizontal graph. Okay, the same thing again, left, because the, if you actually see intuitively, it is on the left side, right? So left should be first gold, then again bronze, and again the silver one. That's what we are doing. Okay, last but not the least, pie charts. What exactly are the pie charts? Pie charts helps you in the segment based observation if the segments are somewhat limited. What do I mean by the limited? Let's say if you have segments around like 15 or maximum 15, that way, in that manner, I'm just talking about here in the real world case scenario, like you can plot it out more than 20 a pie plot for more than 20 segments or 25 segments. That is not the case, but I am just talking about the feasibility and readability of a plot. All right, so when it comes to readability, it is always a good idea to plot lesser number of segments for a pie plot, because everything will just gonna get congested. Okay, so again we do have a method called plt.py. Okay, and for the plt.py, we what we are doing, okay, we have omelette. Being a vegetarian, I still can't get over from the omelette thing. I don't know why. Maybe I find it more fascinating. All right, maybe someday I will make it. All right, so I do have omelette ingredients. Okay, and a percentage ingredient, like how what percentage an of an ingredient will going to play a huge role in order to make an omelette, right? Let's say I just pointed out like 35%. Okay, if we don't have an egg, we can't make an omelette. Oil, of course, like some people can actually avoid oil. I don't know, like spices, of course, and stove. If you don't have the heat, you can't cook it. But it does not come along with the ingredients. Okay, you can't put stove in omelette. Okay, so sorry for that, but it's more of an association to get our omelette done. So that is why I actually put the stove over there in my omelette ingredient. So I may have actually just named it somewhat absurdly. I actually couldn't actually come up with a good name though, like a good variable name. But yeah, we can actually work it out for this session, I believe. Okay, so this is your these are your segments that will going to play a huge role in order to make an omelette, because so you will be having an egg, oil, and spices, and stove, right? What about like exploding the wedges? What do I mean by the wedges? You must have actually had or must have cakes in your lives, right? So, so when you actually cut those cakes in the wedges, like in an arc, basically you just take a piece from a circular, if the cake is circular, of course, from a circular shape, and those circular shape has two arcs from left and right, like, okay, not two arcs, two edges, and it makes a single arc, right? So that is your wedge. Okay, so you can just explode the wedge in order to show a different segment. That's it. Changing the colors again, not a big deal. We just change the color. Okay, and afterwards we are just passing on the colors here, colors, and then yeah, that's it. And showing with the auto pct parameter, auto pct, what it does, it actually gives you the percentage value, how much a segment, how much a segment, gives its contribution in order to make a total pie chart. So we can see the contribution for the egg is 35%, and for the oil it is 20%, and for the pepper it's 5%, for the stove it's 10%, and for the spices it's 30%. All right. uh okay, now comes the histograms. I don't think so it okay, let's actually cover the histograms as well. So what exactly what are the histograms? What exactly are they? Histograms helps you, nothing but your cumulative sum of previous intervals. What do I mean by that? Let's just actually understand this with an example, or something like that. Okay, say you are in a class and where we have an interval. Okay, let's say this interval is from 10 to 15, and this has a value of 20. This interval has 15 to 20, and this has a value of 50. This interval has a value of 22, let's say what, 25, and the value will be, let's say, 15, and this value has 25 to 30, and this is around like 40. Okay, so how exactly I can plot a histogram out of it? So what you need to do is you take bins over x axis. So I say for 10 to 15, what do I have? 20 unit of values. Let's say it is 20. For 15 to what, 20, I have 50 unit of values, right? And for 20 to 25, what do I have? We have, it will be lesser than this, so we have around like 15 unit of values, and for 30 we have the maximum values here. Okay, so that is your histogram, right? So what exactly happened here? It's nothing but your cumulative sum of previous intervals, right? Sorry. Okay, so let's see that in action, how exactly we can print it out. Let's say we have a normal distribution, and since I also mentioned the normal distribution yesterday, let me actually explain what exactly it is. Otherwise you won't understand histograms. Okay, normal distribution usually given by pdf function, sorry pdf function. I'm calling it a function, but it is probability distribution function, and it is being given as p of x is equals to 1 upon root 2 pi e ki power e to the power minus x, like minus x minus mu over sigma square. I believe this is the value. Okay, I don't remember exactly, but I think this is somewhat it is value. Like I just don't. It could be incorrect. I'm not telling you it is correct, but I'm just writing it out from top of my head. Okay, but what I can tell you for this function, what exactly happens here, the moment actually you pass on an x value, mu and sigma, right? So it forms a bell curve. Okay, and the bell curve is follows a rule called 68 95 99.1 rule. All right, so for 68 sorry, every data, what do I mean by that? Every data point in the 68%. So this is your 68% actually, and this is your single deviation from the mu. All right, this is your mean value, this is your bell curve, and this is your normal distribution actually. Okay, so what exactly what 68 actually gives us? It gives us mu minus sigma and mu plus sigma. That is its range. Okay, this is what its range is, and this value forms a 68% of a normal distribution, and this is actually a really useful information. Let's say I am pretty much damn sure that my data set follows a normal distribution, and it's mean. Let's say I have a data set for what heights, for men heights, for India's population, and I know the men's height in India's population follows a normal distribution. Just assume this. Okay, and now I know the mean height for men in India is around, like, let's say 170 centimeter, and that actually varies from what, let's say 10 centimeter. Now I can tell, like, my 60% of Indian population men falls between what, 160 to 160 a 180. This is the most like this is actually a huge analysis and observation. Like, just by this we were able to reduce this. Why? Because we were sure about, like, this is our normal distribution, right? So that is why it is like really useful information when we know about the, Gaussian distribution, if our data follows a normal distribution or not. Okay, and for the same, mu minus sigma will gonna convert for mu minus 2 sigma for the 95%, and of course the left part is usually what it is called, like, the degraded version. Like, not usually, but the lesser, what we can, like, if we actually conclude it with the statistic for the IQ. Okay, so there will be people who will be having IQ of over 200 here, which will gonna fall into only the 0.3%. Okay, and there will be people who will be having lesser IQ, less than 80, will going to fall here. Like, okay, and yeah, and that was your normal distribution. And your smoothed version, if you actually see that, if I just plot it out here like this manner, don't you think it is also somewhat a distribution? So the moment you actually smooth your histograms, you actually tend to get your normal distribution. So what we can say, like, your smooth version of your histogram is nothing but your normal distribution, right? So I hope I have actually made myself clear here about the histograms and normal distribution. Okay, if you do have any question, guides, please put everything into the chat box. I'm taking questions because we need to cover up the modeling as well. For the predictive modeling, we will gonna see a simple example. I can take questions, and I need to drink some water. So please jot down your questions and I will answer them. All right, please do it. Okay, I will, Abhishek. Yes, Aditya, it will be there. Like, you can see the video. What is the use of Seaborn? It is another plotting library. Like, how do we become aware that we have to use the command or function after this particular function? Is this only possible through experience, or is there a procedure that we must follow? Okay, there are some procedures, Sham. Okay, and of course the procedures actually mixed with the experience. Like, the more you follow up the procedure, the more you are getting the experience. Okay, so you should actually get cleared about why you are plotting out something, upon what basis, right? What is your hypothesis and what is your evaluation in your mind? Like, okay, now I need to plot out a bar plot, maybe a stacked bar graph. It should actually comes from your intuition. I can tell you right now, but it won't be good in a longer run. Okay. Abhishek asked me like, yeah, sure, Abhishek. That is it. So this is your actually subplot. Okay. So actually you see the subplots here. Let me just go again to any of these subplots. There you are. So you can actually see, like, right now, like, just consider this as one row and two columns. You could have two rows and two columns as well, and in that way it will just gonna it will just gonna render out four plots, one two and up again one two, just below them. Okay, so for that, after 1 by 2, I'm telling for the number one plot, plot number 1, it should have these attributes, and for the plot number 2, it should have these attributes, and then I am adjusting those plots. That's what I am doing. Okay. What is the use of Seaborn? Yeah, again, I answer, sir, how we can take data from .csv file to draw the plot. Okay, just use pd dot read csv that we saw yesterday, and you should be good to go. Then when to use matplotlib and when to use Seaborn? Okay, Seaborn helps you in other factors like plotting out the distribution plots. Okay, it won't be possible to cover up everything right now, honestly. This is somewhat I have. Okay, if you actually see that in action, like, okay, this is your whoever was asking, like, this is how you can actually read a csv file. Okay, so there I am actually using sns.facetgrid like Seaborn. Okay, so Seaborn is another mat like plotting library, but since we need to cover up the predictive modeling as well, like, it will just gonna be somewhat same in order to scattering and only for the visualization part. But yeah, it actually helps you to plot out different sort of plots like pair plots, and this, like, in this manner, like a distribution plot. Sorry, this is actually a scatter plot, but you can do same with the matplotlib as well, plt.scatter, and pass on the setosa versicolor and virginica, and then pass on the label values, and then you should be good to go. All right. Again, then for, of course, the pair plots as well, but it won't be possible to cover up everything in this session. Okay, so sorry for that. Any questions? Any questions? Nope. Okay. All right. Okay. Nope. So let's actually start with the machine learning, because that's it. That is what we had in our minds. Like, this is an essential, basically. You can actually consider it as a crash course for data science. Okay. And let's be honest here, guys. Like, I have been doing my ML for last maybe 3 or 4 years. Okay, and that is why I am quite certain about some functionalities, certain about some procedures, and how to approach any, like, most of the problems. Okay, because I have dealt, like, I don't know how many times, I don't remember. Okay, so it is not possible to cover up everything in 1.5 hours of session. You, right, you do get that, right? So what we can do here in essentials, we can just provide you a good and better understanding of what exactly a topic can be used in your domain. And then, yeah, and afterwards, that is your call, how you would like to proceed. Okay, explain about box plot right now. Box plot. Okay, I can explain about you box plot. Sure. How many of you actually know about the interquartile range IQRs, median and mean? Okay, better. I have here, like, there you go. This is your box plot, right? This is what I am uh, roughly sketching over there. So you just don't get confused. I'm just, giving it here. Okay. So this is your interquartile range 1. This is your interquartile range 3. And this is your median. Okay. And this is nothing but your percentile value. And what exactly do I mean by the percentile? How many of you actually know about the percentile? Okay, when you have an value in an array, and the value has to be numerical, and of course not log in order to get them sorted. Okay, I'm not talking about the index. You can have a percentile value for the categorical values as well, but you have to assign index to that, and also some certain values. Okay, so let's actually stick to the numerical values right now. Okay, so you have 1 to till, let's say, 1000 values, and I can say, when I say 50th percentile, what do I mean by that? I mean by that, like, for this median value, sorry, this median value, let's say it's x50. For this medium value, all of my these value will gonna be lesser, right? And when I say x75, this is my interquartile range of x75, like percentile 75 basically. Okay, now I can say for this value, my 74% will value going to be, lesser. Okay, this is what your box plot shows you. This is your minimum value, this is your maximum value, right? These are called whiskers. Sorry for the spelling. Okay, and what we can tell from IQ 3 minus IQ 1, what we can say, like, 50% of our data lies within this range. And this is your 75%, of course, because this is your 75th percentile. Okay, and this is your 25% of the data, and of course it is again your 25% of the data. All right, so this is your box plot, guys. Basically, it tells you 25th percentile, then median, then 75th percentile, and those percentiles are known as IQ1 median and IQ3. I hope I have made myself clear here, Kiran Babu, right? Okay, moving on. So how many of you actually how many of you actually have done some sort of predictive modeling or machine learning? And how many of you actually know about the machine learning in the first place? Please let me know in the chat. because we will be just seeing an intuition and a simple linear regression example. That's it. Okay, you're welcome. Anyone who has done some machine learning, please let me know in the chat. Okay, so meanwhile I'm going to write some mathematical functions here. Great, Aniket has worked with the machine learning. Great. Okay, and I can say x or y, hand gesture recognition. Great. Know the term, that's all. Okay, so just for a while, okay, I know that's actually goes against this lecture, but just for a while forget about that. We are here for machine learning. Just assume yourself that you are here for a mathematics class. Okay, and I can actually assure you guys, like, it won't be a boring class. Okay. All right, so yeah, so just assume we have 20 minutes or so. Let's focus upon entirely upon what I am going to tell you, and it might actually give you a good superficial, not superficial, like a good understanding of how exactly machine learning, works under the hood. Okay, let's say we have this. I'm talking about here linear regression. Okay, so before actually diving here for the linear regression, I would love to tell you a small story. That's it for the machine learning. Nothing jargon, like no more technical jargon. Just a simple story, and I would love to have your constant response in that. Okay, what do I mean by that? Let's just see. Let's say, assume yourself as Billy. You are Billy, all right, and your mom asks you to assemble three boxes: box A, box B, and box C. Okay, and these three boxes has uh, like 100 what apples. Each box has 100 apples, but let's write it here, because each box 100 apples. All right, but let's just see here. Let's say in the A box we have around like 10 to 15 rotten apples. For the B box we have 15 to 20 rotten apples, and the C box we have 20 to 30 rotten apples. All right, let's just assume this. And these are the boxes, and each box has 100 apples. I believe everyone with me is here till now. Okay, and his mom actually asked for 100 boxes. So we have 100 boxes of ABC: box A, box B, box C, box A, box B, box C, box C, A, till what? 100. We have a gigantic trunk which actually holds these 100 boxes. All right. Okay. So now Billy has a task. What Billy needs to do, he needs to, he needs to actually take out these boxes out of the truck and assemble them: A over A, B over B, C over C, basically making the stack, right? Okay. So after a while, let's just assume, after a while, after 65 boxes he has placed, let's say he has placed 65 boxes total. That actually constitutes of A plus B, sorry, B plus C. These are your 65 boxes that he has placed here: A, B, and C. All right, but what about the 35 boxes and why he couldn't place them? Why couldn't he, stack them over their respective label boxes? Reason was because the labels got removed. Right now, what the boxes that we have only this and an empty labeled box, like we don't have any labels on them. Now this just actually just become a quite an interesting problem if you see from an teenager's perspective. So Billy was quite smart, and he actually noticed it already. Okay, he knew it. Like for the box A, he had around like 10 to 15 rotten apples. For box B, he had around like 15 to 20 rotten apples, and for the box C, 20 to 30, right, rotten apples. So what he did, he just came up with a simple math, just a pseudo programming math. Okay, like nothing Python, nothing R. Okay, what he did, what he did, he just wrote a simple example. He just wrote a simple pseudo algorithm, which was like if the rotten apple in the range of what 10 to 15, it belongs to A. 20, 15 to 20, it belongs to what? B. And for 20 to 30, it belongs to what? C. Okay, even though Billy has no idea about machine learning, he just performed a lightweight classification task. Why am I calling it lightweight? Because firstly, I like the name lightweight. Okay, and for the classification, because he literally classified those boxes, which didn't have any labels on them, right? And this is what your machine learning is all about, right? You are given the data, you come up with a mathematical model, you pass on some data to the mathematical model, and that mathematical model spits out a prediction. And how exactly it does, like this is an entire study about, like entire domain to study about machine learning that we call, right? But yeah, that is how you actually make prediction, right? So this is nothing but your simple a classification task. Simple. Why am I calling it simple? Because it could have been done with a simple function. But where did we actually use machine learning in that? Well, you should be asking me this question, because I didn't have to write those gigantic neural networks, or those complex algorithms, or anything that you have heard or wrote or studied about till now. I just completed it with the simple if and else condition. So where exactly I could actually use machine learning. Okay, let's actually see that in much more detail. Let's say let's say you have now you actually want to figure out for let's say you A, B, and C boxes were delivered by different truck drivers, and those different truck drivers. So initially, what label did we have that we need to predict? Was the rotten apples, sorry, was the A, B, and C. Okay, but upon what features? Like we only had one feature. What? Rotten apples, number of rotten apples. Let me actually have it here. We had only a single feature here: number of rotten apple number and the label, right? If the rotten apple number is 12, this much to this much, it will just gonna give you A, and so on. We saw it already. Okay, but this was only a single feature that we could able to easily handle. But in machine learning, we tend to get around like sometimes even 1,000, sometimes even for the MNIST data set. If you actually get into that, we have around like 764 features there for each pixel value. Okay, so believe me or not, when you will be dealing with 20 or more than features, 20 or more features, in that manner you won't be able to deal with huge data. Okay, so what we can do in that case, like we are not talking about anything right now about the complex machine learning algorithms, or just it is only from the intuition's perspective, right? We are not getting into any complex jargon. Okay, so let's say if I introduce here x1, y1, and along with the rotten apple, I can also introduce, let's say, 50 more features, like from which route, the driver came from, so the labels got peeled off, right? Who were the vendor, how or how actually apple actually got rotten, like how fresh they are. Like there could be many features in order to deduce if it actually belongs to a or b, right? So in that manner what we do, we come up with mathematical operations. What do I mean by that? Let's say, let us assume, okay, let us assume, how many of you actually know about this? It's nothing but your y is equals to mx plus c, right? So what if I could have a decision surface, or I could have a simple line that could segregate my three classes. Let's say if I have simple line, I have like this this. What if I could have a simple line like this that could actually segregate this? So yeah, again a problem, like it was segregated really well, but not this one. So this is again a huge case, again a next case for, like, this is, that's where your polynomial functions actually comes and plays a huge role. Okay, so what we do, like we actually build a curvature like somewhat like that, but it is actually a overfitting case. I'm just building it out right now, but it is an overfitting, guys. Okay, so you might actually see this lecture in your future and see, okay, Gopal actually told us about something that was actually or that mathematical model was an overfitted one. But I am telling you, before you actually point it out. All right, I can't take risks. Okay, so yeah, so that is how we actually plot it out. Like we take decisions. Okay, and we take decision surfaces, we actually call them decision surfaces in classification. Okay, even in the regression. Okay, and what we do, let's say we have this, so we try to reduce this size. Okay, and how exactly it is being done, you should be asking me. Okay, say I have predicted a, b, and c. I have predicted it, but who will gonna tell me how accurate it is? I can say anything I want. Okay, I can say literally anything I want, but what is a metric? What based upon what metric I am deciding, like, okay, I am this much percentage of sure I can tell about with this probability, like this actually belongs to a class, or this actually belongs to b class. Okay, that's where your metric system comes into play, that we actually study about the, for the regression it is always most of the time it is mean squared error, r square error, and mean absolute error, mean absolute deviation, and so on and so forth. And for the classification we have like the log loss, most used log loss. Okay, and of course the sigmoid one as well, like that is actually built with the log loss. And okay, and yeah, QWK as well for the agreement to agreement percentage. There are a lot, like there are lots of metrics like precision recall is there. Okay, ROC curve is there. Okay, for the classification I'm talking about, but for the regression there are less metric evaluation techniques than the classification ones. Okay, that we won't be able to cover in next 10 minutes, sorry. And yeah, let's just actually see that what do I mean by the regression here. Okay, So let's just say you have a model y is equals to mx plus c that segregates, or that's actually predicts, not segregate, sorry, I take back word the segregate here, not segregate. Okay, I am talking about here right now about the regression. Okay, what exactly do I mean by that? Your y belongs to r, that's it. Okay, and what do I mean by the r? R here represents the minus infinity to plus infinity, and I R and your y has to be a continuous value. Okay, what do I mean by the continuous values? 1, 2, 3. These are also integers, but these are classes when you will be dealing in the machine learning. These are whole numbers. Okay, but the moment I say 1.1, 2.1, these are the continuous values. Okay, so your output has to be a continuous value. So how can I represent this? I can say x also like this. Okay, right? This is your simple linear regression. Okay, how exactly it works? It takes it takes a single feature, and for the feature, let's actually understand the feature data set, like feature matrix. How exactly it works? Because if you don't understand this, it will not gonna work. Okay, so feature matrix is your like this. Okay, so for let's say x1, x2, x3, x4, it actually gives you y1, and again xi1, let's just say x11, x21, x31, and x41, and let's just assume, let's say x21, x22, x32, and x42. It actually gives you y2, and so on and so forth, right? So what are these? So what you do, these are your features that actually helps you to build a mathematical model, or a model that predicts these labels. These are your labels. All right. So when I am saying features and labels, what do I mean by that? So what I mean by that, sometimes we don't have labels. So it brings a new concept for us. It brings a new question for us. Like, okay, when we don't have labels, what do we call it? Okay. So when we have labels, it is called supervised machine learning techniques. Supervised machine learning. And we don't have labels, it is called unsupervised. All right. Okay, makes sense, right? Why? Because we don't have any labels here, so we tend to cluster the data. We tend to do some insights or reduce the data dimensionality, and something that we do with the clustering. Most of the time we do clustering with the unsupervised one, and for the supervised one, it comes along with the classification and regression. Because for the classification, you could have a class like that you want to predict a, b, and c, and for the regression you could have a price that you want to predict. It could be 12.5.4232, anything. Okay, and that is how it is. Regression technique, classification, and regression are comes under the supervised machine learning, and for the clustering it comes along with the simple unsupervised. We are only given the features, or per se only the x values, but not the y values. Okay, y is not available here. All right. Okay, so how exactly the your linear regression works? So you give some x1, x2, x3 values. You are given y1, y2, like, okay, y3, yn. So you train the data on this one, this features data. Okay, so to train the data, what we do, we split the data into two parts. First one is the training set, and second one is the test set, to test out the model. What do I mean by that? Sometimes it is also called holdout data set or unseen, basically. So why? Because it obviously doesn't make sense to train your model on the testing set, because it just helps you to decide how much our model is giving us right prediction. And for the training one, we tend to find our parameters that actually best, that helps you to best fits the data. What do I mean by the parameter here? Okay, parameter is nothing but your y is equals to mx plus c, right? Okay, so m is here your parameter, c is here your parameter. What do I mean by the best fit? When you write, when you actually see that in action, this and maybe this, and you have a data somewhat like this. Okay, you can tell from l1, l2, and l3, you can say seriously, like l1 best fits the data. Why why I can tell, like, for l1 my m1 and c1 will going to be different. I know I actually draw them out from the origin, but let's not assume that from the origin. And m2 and c2 will going to differ from the and same goes for this m3 and c3, right? So what we do, we tend to find these optimized values, m1 and c1, right? These are your parameters that we tend to find in any machine learning algorithm, like in any machine learning task. Most optimized ones that gives us least error and best results. Okay, to actually sum it up everything right now, let's actually perform a simple linear regression task, and let's wrap up the entire session for today, for tonight. And please get ready your question for next. I can actually stress this session for 9:40. Ready your questions if you have any, and I will answer them. Okay, and let's actually just make a new Python notebook, and let's just call it LR. Okay, so for performing machine learning, we have sklearn. Okay, so what you can do, simply install sklearn. I believe I have already installed it. Okay, we do have sklearn. Okay, so I'm going to give, like, from sklearn, from data sets, import Lord Boston. Okay, these are our libraries that we will gonna use. Okay, this is nothing but your x and y data set. Let's actually call it out here. Data is equals to load Boston, and it actually gives you a dictionary of what? Data that we just talked about earlier, right? X values and target. So let's extract them. So this is nothing but your dictionary. So what I'm going to say, x is equals to data of data. We are just accessing the key value here, and afterwards y is equals to data of what? Target. Sorry, I have now x and y. Let's see the x dot shape and print y dot shape. Okay, now we have X and Y. The next step that we need to do, split the data to test out on the training, to test out our model on the testing data set, and to train it on our training data set, right? So what we will gonna do is we're just going to split the data in four parts. Train, test, split. Okay, now we have X and Y, and test size zero point 0.2, and afterwards random state, what it is. That's integer doesn't matter. What exactly the random state does, it produces the same uniform data set for each iteration. Okay, so let's say you actually rerun your code for let's say 10 times, and it will just gonna give you 246 246 246 for each iteration. That helps you to give, that actually helps you to yield a uniform data that builds a better and robust model. So I'm just going to pass here one. Okay, so let's now actually call our simple linear regression model. So I'm just going to call it like now linear regression. Okay, lr dot fit x train and y train. Okay, now we have fitted the data. What I actually talked about, it has to be the what, the coefficient, of course. Okay, so we have coefficient here. So you can see the coefficient value is this. Okay, just right now it might actually uh, intimidate you, startle you how exactly we came up with this, but it's more of a linear algebra. We tend to find those value with the w transpose w, like we do some matrix multiplication, that's where we actually get it. Okay, so just, you know, if you can actually google it out, please do it. Otherwise, maybe sometime else. Okay, and this is your intercept. Okay, and now let's actually see how well our model is doing on the X train. Sorry, like the training data. So let's see the score value, X train and Y train. It is around like 73%, and our dot score X test and Y test. It is around like 76%. Quite good, right? Let's actually predict something and let's see. So print, uh, let's say original value from test at zeroth index is what is this, let's say y test of 0 is this much, 828.02. I want to predict the value now, y test of 0, and it takes value into the array form. Okay, so just give it into the array. uh, 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 okay, 2D array, simple and subtle. Wait a minute, I believe sample y test of 0. I need to check. Okay, so sample, what the hell is happening? uh, mm, just a sec, guys. Let's actually see that on the test set, and this was on the, why it is not working, it should work. Predict, let's actually see that in the documentation. Okay, right, and yeah, it doesn't give any answer. Oh, white test 0 should actually give you an answer. I don't know why it is not giving you. Like, let's say y test, we actually give a simple y test, but still it is not giving you any answer. I don't know what is happening, guys. Here, like we can actually reshape it out and into -1 and -1. Let's see. Nope. Hmm, why it is not giving any answer? No, guys, I think I gotta see that. Like, it was working uh, the moment, like maybe 2 or 3 months ago. Let's actually see that in linear regression, sklearn. Okay, and come in here. Yeah, that is what I was using reshape, bro, for the fit, for the predict. That is what I am using actually, and still it is not working. I don't know why. Let's actually rerun this. Okay. Mm-mm-mm. Okay. Let's actually have this here. Like np.array, it is already an array. I don't know why it is not giving any answer right now. np.array, and let's actually see like, oh, shit, shit. Okay, I actually just got fumbled up here. Yeah. All right, my bad. I actually was predicting the label and no one actually found it. Okay, okay, fine. It should work now. Okay. Actually, what I was doing. I was actually taking the y value instead of the x value. You know, just the mind, it can, sometimes be crazy. Sorry for that. I was actually taking the y test instead of the x test. Just I was in the hurry to actually, see that in. Not the x, not the reshape, bro. Okay. Yeah, I just actually figured it out afterwards. All right. So, any more questions? Okay, so I will be. Any questions if you have, guys? Nope. So, can we actually end the session now, Umang? Day two के assignments कहाँ हैं? I told you guys, like whatever we have covered, just like we didn't have anything. Like, okay, I can make an assignment and send it to you over the file. Okay, thanks, Abhishek. So, so it's almost 9:40. Okay, and mentioned as JavaScript instead of Python in data science. I don't know. Like, I don't know about it. Thank you, Abhishek. Okay. All right. For the day three, you will gonna get for all of the materials that you are asking for. Okay. Don't worry. All right. So I will be ending the stream here. Okay. And I don't see.